Okay, so this is 4.2, part 2. If you notice the directions for these problems with the graphs, it says write an equation in slope-intercept form for the lines shown. You can do everything that you did in 4.1, find the slope of the line, find the y-intercept in order to be able to write your equation in slope-intercept form. I'm going to do something slightly different. That might be easier for some people. If you can do everything that you did in 4.1 and find the slope and y-intercept, do it that way, that's fine. But here's what I'm going to do since we were just talking about point slope form. Remember, point slope form looks like this. Y minus y sub 1 is equal to m times the quantity x minus x sub 1. So what that means is I need a point on the line. On exercise or problem number 7, I'm given 2 points, and then I need to figure out the slope of the line. Okay, so I could either use this point or this point when I plug that into point slope form. It actually won't matter. I'm only going to use one of them, but if you use the other one, you should see that you'll get the same equation in slope-intercept form. You also need to find the slope. So I'm going to use these 2 points to find the slope. Remember, start at the leftmost point in order to find the slope. Use rise. So here's the rise. Up 1, 2, 3, 4. So the rise is 4. And then the run is 2. So the slope, or m, rise over run, 4 over 2, or 2. And then here's what I'm going to do. I'm going to label this point 1, negative 2, x sub 1, y sub 1. Because I'm going to write the equation in point slope form first. So if this is x sub 1, y sub 1, plug it in this equation or formula. Y minus y sub 1, so y minus negative 2. That's the same as y plus 2 equals m2 times the quantity x minus x sub 1, so x minus 1. So this is point slope form. You always have to make sure that you read and follow all the directions, because some people might think that they're done if they write the equation in point slope form. But like I mentioned, your equation needs to be in slope-intercept form. So slope-intercept form is y equals mx plus b, or in other words, it's solved completely for y. Y is isolated or all by itself. So I can get y all by itself in this equation. Here's the first thing that you need to do. And if you have an equation in point slope form, here's what you always do. Distribute the slope. In this case, I'm distributing the 2. So I'm showing all my work. I'm just going to bring my work up here. Y plus 2 is the left side. And then on the right side, 2 times x is 2x. 2 times negative 1 is negative 2. Okay, and that's starting to look like slope-intercept form, except we need to get rid of this 2. So to get rid of the 2, to solve this for y, I could subtract 2 from each side. Subtract 2 from this 2. You have to subtract 2 from the negative 2. Both of those are constants or just numbers. I cannot subtract it from the 2x because those are unlike terms. 2 minus 2, 0. So you're stuck with y. 2x just stays the same. And then negative 2 minus 2, negative 4. This equation now is in slope-intercept form. So we started with point slope form and then changed it into slope-intercept form. Okay, on my next example, I'm going to go over problem number 12 here. So I still want to write my equation in slope-intercept form, except I'll show you again how you can start with point slope form and then change that to slope-intercept form. So for point slope form, I'm going to use a point. I'll use 1, 2. You could use 2, 0 as well. That would work, but that's x sub 1, y sub 1. That's a point for point slope form. And then we also need the slope. So again, for the 5th or 6th time, in order to find the slope, start at the leftmost point. Here's the rise, negative 2. So you're going down 2. I'm just going to write it down here, negative 2 over the run. So the run is positive 1. So the slope, or m, negative 2 or negative 2 over 1. You can write it either way. But then for point slope form, I'm not going to rewrite all of this, but I'll use that in order to plug in the point and the slope. So again, this is the point that I'm using, 1, 2. That's x sub 1, y sub 1. So then point slope form looks like this. Y minus y sub 1, which is 2, is equal to m negative 2 times x minus x sub 1. But then I want to write my equation in slope-intercept form, so I need to solve this for y. Like the last example I said, you have to first distribute the slope. You have the parentheses on the right side, distribute the negative 2 into the parentheses. So it's y minus 2 equals negative 2 times x is negative 2x. Negative 2 times negative 1 is positive. And then to solve this for y, add 2 to each side. And then your equation should be, if you can see this at the bottom, I'm going to scoot it down a bit so you can see it a little bit or a lot better. But y is equal to negative 2x plus 4, which is slope-intercept form. Okay, if you don't believe me as far as you can use either of the points, try it with 2, 0. I'm going to do that real quick, but you can try that as well. And I'll show you in the end, you'll get the same equation. So now if I make this x sub 1, y sub 1, the equation becomes y minus 0 is equal to the slope we found earlier, still negative 2. Regardless of what point you use, you still have to find the slope, times x minus x sub 1, so x minus 2. And then I distribute the slope to put it in slope-intercept form. First of all, y minus 0 on the left side, that's just y. And then on the right side, negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. So see how we get the same equation? Maybe this point would have been easier to use initially to find point slope form and then slope intercept form. But I was just wanted to show you that regardless of what point you use, you get the same final equation for slope intercept form.